Okay, so here's an example problem to demonstrate what we were just talking about with different concentration units. This is number 13.41 from the book. And another good example to look at would be 13.43, I think was one of the suggested bookwork problems. So this question is asking us, in different concentration units, let's look at what the different concentration units are. If you have 14.6 grams of CH3OH methanol and 184 grams of water. So the first one I asked about is the mole fraction, which is, like we said, just the moles of the component we're looking at over the total moles present in our solution. So all you do is calculate the moles for each one. Pretty easy. You guys definitely know how to do this. 14.6 grams divided by 32 grams per mole, just by adding up the masses of each component in the molecule. And then you calculate to be about 4.6 moles, round it up a little bit. And then same for water, 184 grams divided by 18 grams per mole. You get 10.2 moles total for the water. Then you add those two together because we're taking the total moles of our solution. You can't just take the moles of the solvent, it's total moles. So 0.46 moles of CH3OH divided by the sum of the methanol and the water, and you get 0.043 is your mole fraction for the methanol. And then, now that we've calculated the moles for each one, the mass percent and the molality are pretty easy. So for our mass percent, we just take the mass of the component divided by the total mass times 100%. It's pretty similar to the mole fraction except with mass. So just 14.6 grams of methanol divided by the sum of the mass of the methanol and the water times 100%, 7.35% of our solution is methanol. Similarly for molality, except now we're taking kilograms of our solvent rather than total mass of our solvent and the moles of our solute. So 0.46 moles of methanol divided by 0.184 kilograms of H2O. You have to convert over from grams. Comes out to be about 2.5 mole.